Alright, let's talk a little bit about digital modes and non-voice modes. So not everything we're talking about is necessarily digital, but these are non-voice modes. One of the first questions within this pool of questions is what from the following is a digital mode of communication? And they give you a few options. They give you a single sideband, which we call SSB. They give you voice FM. They give you what they say is, amateur radio television. We often call that slow scan television. They also then give you one called packet radio. And so from all of these, and when we talk about modes, or as you're studying, and if you've hopefully already learned a little bit about AM and FM and phase modulation and single sideband, you'll know that those are analog. Those are not digital modes. So that means both of these two are out. Amateur radio television is not a digital mode. Packet radio is the only one that's left. And what this means by a digital mode is that it means it's something that you cannot interpret on your own with your own ears without converting the information for you. If you've ever listened to a fax machine or a modem, you'll know that you don't know what that information coming through is from the sounds. But when the fax machine puts out the piece of paper, it's intelligible for you. You can read it down. When the modem puts the information on your computer screen, it's intelligible. It shows you either a picture or the text or whatever it is, the image. Packet radio is very much the same way. If you hear packet radio on your radio, you're not going to be able to tell what it is. It's going to sound like a modem. It's going to sound like like some sort of digitized message, and you're going to need something to convert that. And so there's usually what you need is a TNC, or a terminal node connector, between your radio and probably a computer that will then translate that data and make it intelligible for you. So packet radio is a digital mode. You can't understand digital modes unless there's some sort of translator at the other end. So that's the correct answer to that one. Now let's look at some other items here as well. We have APRS, which stands for Automatic Positioning Reporting System. Or I think it's Automatic Position Reporting System. APRS is a really great tool for search and rescue. They particularly use this a lot. A lot of repeaters, even in the mountains and the Rockies and things, are APRS repeaters because they can find your location and talk to you if you're on the search and rescue team. And of course, you can't always talk to them, but they can find your location. That's extremely important in search and rescue, and especially when the conditions are failing and the weather is not ideal. Now, in order for that to work, it requires something else, a GPS. And I think we all know what a GPS is, Global Positioning System. That uses satellites, of course, to determine your location. We have an APRS radio in one of our vehicles, and it actually has a little plug on the side that you plug your GPS into, and then you can activate the APRS system within that radio. Now, something else that APRS is very popular for is a lot of guys on their tower will have a weather station, or on the side of their house or somewhere like this. And they actually have the weather station hooked up essentially to a radio, to an APRS radio. And that APRS radio is telling the National Weather Service their location because it's hooked up to GPS, and it's transmitting the data through APRS of the weather station. So the National Weather Service can see what the weather is and what's happening, how much rain, how much hail, how much whatever, what the wind speed is at that location. And when all these APRS stations from the amateur radio operators all over your area are reporting, the National Weather Service gets a very clear picture of what's happening in all these areas. So that's APRS, Automatic Position Reporting System. There's also a question about NTSC, and we're not going to talk much about this. Just basically, the question asks you what type of transmission is indicated by this term, and the correct answer is a standard fast scan color television signal. So fast scan color television signal is the correct answer when you see that acronym there. PSK, let's talk a little bit about that. PSK stands for Phase Shift Keying. Okay, and the item that we particularly use in amateur radio is PSK 31. And if you go for your general exam, you'll actually need to learn baud rates, which is like how fast these things are sent and whatnot. And you'll learn a lot more about PSK 31. The questions within this pool are pretty simple. First of all, they'll ask you what PSK stands for, Phase Shift Keying. So I'm also going to ask you, what is PSK 31? And the correct answer is it's a low rate data transmission that works well in noisy conditions. So if you remember the noisy conditions, that's the only option on that question that has noisy conditions in it. So it's low rate data, and it works in noisy conditions. So what else do we have here on this question pool? Well, we have some questions about Morse code. When you're sending Morse code, what's the best speed to use? Well, the best speed to use is going to be the one that you can copy at. So don't send Morse, just because you can send fast, don't send it faster than what you can receive it, because the station that responds to you is going to assume that if you're sending it that fast, you can receive it that fast. And that's also, if you're a fast sender Morse code and somebody sends you code very slowly, don't respond to them very fast. Like, respond at the speed that you received them from initially. And what is a practical reason for knowing CW or Morse code? CW stands for continuous wave when using repeaters. Well, we talked about that already as well. That's so that you can figure out what the identification of the repeater is. A lot of times the repeater ID is a Morse code symbol, or Morse code signal, I'm sorry. And so when you hear the signal, you'll be able to identify the call sign of that repeater and any other information that might be coming across in Morse code. There are some Q signals that we use in Morse code, and your book that you have should list all the Q signals, or at least a good chunk of them. You can find them on the internet as well. Of course, we talked about QRM already. QRM is harmful interference. One that's not on your exam that you'll hear a lot when you're on the radio is QTH. And QTH means like your home or your base station. So like, what's your QTH? Well, my QTH is Sarasota, Florida. All right? And, don't be intimidated when you hear all these. You'll learn them with time. The other ones that we want to look at here is going to be QSY. And that's a really common one. When you say, I'm QSY to 145.13, that means you're changing frequencies to the 145.13 frequency. And so when you're going to change frequencies, like if you just sign off, people might think you're still there listening. So if you're changing frequencies, you can say, give your call sign, this is KJ4FCZ, I'm QSY. That means you're changing frequencies. So you only need to know these two Q signals for your exam, but there's many more, and I encourage you to look at the list, and as you get on the radio, you'll learn all about them. All right, we'll talk more about modes next time.